So if I want to take the cosine of 2y, what rule am I going to use? The chain rule. Okay, what's the derivative of cosine? Negative sine 2y times what? 2 dy dx. Good. Okay, so the derivative of cosine was negative sine. You always keep the same argument, and then the derivative of the argument, or the derivative of 2y, is 2 dy dx. Equals what? 1. All right, this one's fairly simple to solve for dy dx. I basically just need to divide by negative 2 sine 2y. So dy dx equals negative 1 over 2 sine of 2y. And you could have put the negative on the bottom. I just tend to bring negatives up to the top because I personally lose them sometimes. Find the slope of the tangent line to this graph at the point 3, 1 and write the equation of the tangent line. Okay, we know how to write the equation of a tangent line, right? We just need a slope and a point. I actually have the whole point, so I don't even have to figure out what the corresponding y value is. A lot of times I just give you the x value. So all we need to do is find the slope. All right, so to find the slope, how am I going to do that? Chain rule, good. We're going to do 6 times x squared plus y squared to the first, and then times the derivative of that parenthesis. Perfect. 2x plus 2y dy dx. So is that dy dx just with the 2y, or is it with the 2x also? Just with the 2y. All right, and then I'm going to have to use the product rule. So the derivative of the first one is 100 times y, plus the first one is 100x times the second one is dy dx. Mm-hmm. Yes. It's from taking the derivative of just x squared plus 2y. So the derivative of x squared is just 2x plus, yeah. Product rule. Using 100x as one of my factors and y as the other one. So the derivative of the first one, derivative of 100x is 100 times the second one is y, plus the first one is 100x, and then the derivative of y is dy dx. Okay, now we need to solve for dy dx. So I need to get everything with a dy dx on one side, everything without a dy dx on the other. The problem is that this dy dx is kind of embedded in this parenthesis that's being multiplied by that parenthesis. So I've got two options. One, I could FOIL out those two parentheses, but that's not very appealing to me. The other is that I can treat this as a chunk of something and distribute it through the second parenthesis. So I'm going to take this whole chunk times 2x plus that whole chunk again times 2y dy dx. Is that easier than foiling, do you think? Tamara? Okay, if I divided by the first chunk, I like the word chunk, by the way. I'm going to use that a lot this year. If I divided by the chunk that I've circled right here, I'm going to have to divide this term and that term. And now I've got a dy dx that's kind of divided by something. I guess it wouldn't be... You can do that, but it's going to be messier than if we do this. All right, so when I distribute that chunk, the 6 times 2x I'm going to write as 12x, and then times the x squared plus y squared, plus, and the 6 times 2y I'm going to write as 12y, and then x squared plus y squared dy dx. Well, I've got 6 times this parenthesis times 2 times x. So I just went ahead and multiplied the 6 times 2x. I think y'all are getting confused with distributing through pluses and minuses and just multiplying multiple things together. Like if you're multiplying 5 times x times 2 times y, that's just 10xy. And that's all I did with the 6 and the 2x. And then still kept it times the parenthesis. Okay, so I'm going to pull my dy dx's over to the left. So I'm going to have 12y times x squared plus y squared minus 100x equals 100y divided by 12x. No, sorry, 100y minus 12x. And then I need to divide by this big bracket right here. Anna? This represents the slope. Now, where am I wanting to find the slope? At 3, 1. So, the slope at the point 3, 1 is going to be 100 minus 12 times 3 is 36. X squared plus y squared is 10. 9 plus 1. And I'm going to have 12 times 10 minus 300. This is not too bad to do by hand, really, because you've got 100 minus 360, which is negative 260. And 120 minus 300 is negative 180. So 26 over 18 or 13 over 9. Yes, I would probably let you use a calculator if the numbers were that big. It's lost. Down here. Because I was multiplying the 6 times the x squared plus 2y times 2y dy dx. So I simplified the 6 times 2y to get 12y. Like So I was distributing to that part. So I had 6 parenthesis x squared plus y squared times 2y dy dx. And since it's all multiplied together, I just took the 6 times 2 times y and pulled it out in the front. Okay, so then the equation of the tangent line would be y minus 1 equals 13 ninths times x minus 3. It's a lot of work. And that's pretty much as hard as it gets. All right, now this is the reason why I want you to, instead of, like someone asked, can I write y prime instead of dy dx? The reason that I want you to write dy dx is because on this one, we're taking an equation that involves both the x's and y's, but now we're going to differentiate with respect to t. So anytime I take the derivative of y with respect to t, what do I need to write? dy dt. And anytime I take the derivative of x with respect to t, I'm going to have to write dx dt. Good. Megan, do you have a question? Okay. Okay, that's a good question. It's actually, we're not going to, Gray's basically saying, do I need to solve for dy dt or do I need to solve for dx dt? We're not going to do either. We're just literally going to take the derivative and stop. So the good news is when you introduce a third variable that you're taking the derivative with respect to, you don't have to solve for anything specific. I've got a little bit of an option here to start off with. I could use the product rule with x squared and then times that parenthesis. Or what else could I do? I could distribute the x squared. Now, I'm still going to have a product rule. But to me, it looks a little bit simpler after I've distributed it. I don't know about you, but... All right, so the derivative of x to the fourth with respect to t will be 4x cubed dx dt plus. Okay, now I'm going to have to use the product rule with x squared and y squared. So the derivative of x squared, 2x dx dt times y squared, the derivative of the first times the second, plus the first, or x squared, times 2y dy dt. Equals 2y dy dt. Done. Yeah. Now see, where this is going is, like, we're going to have a triangle. And no, we don't need to put the d. It didn't specific, like the directions on the other ones said specifically find dy dx, and that means solve for dy dx. So I guess if this had said find dy dt, then I would want to put the d, solve for dy dt. But since it just said take the derivative of this with respect to t, that's fine. Okay. Where this is going is that we're going to take like the area of a triangle, and given that the base is changing at a certain rate and the height is changing at another rate, we're going to find how the area is changing. So we're going to take the area of a triangle and we're going to want to take the derivative with respect to time, because as your base is changing and your height is changing over time, we want to know how that's affecting the area. So that's where this is going. All right, I think it's number 6, the last one.